Okay, so first video we're going to do regarding TinkerCAD is we are going to create an account, and then I'm going to show you how to do a basic circuit called the blinking LED. Now, the one thing that's different about what you're going to be doing in class versus what you will be doing at home is the students that are here are actually coding these circuits. We're going to be using something called a Arduino Uno, which is a little microcontroller that allows you to actually program some certain things. So instead of just having a basic circuit that powers a light, we can actually program the board to blink at a certain interval. So we're going to create an account, and I'm going to show you how to do an LED circuit. Then once we get to the end, I'm going to give you a challenge question, which will be your homework for the week. So let's go ahead and get started. So first thing I've done is I'm going to sign out of my current TinkerCAD to show you what you need to do in order to get logged in for yours. So, one moment please. If you go to www.tinkercad.com, and I will leave that in your description at the week at a glance, this is where you would go to create your account. So you're going to hit https://www.tinkercad.com, and we're going to hit this join now button up at the top right hand corner. Once you hit the join now button, it's going to ask you to either join a class or create a personal account. I have not actually created a class, so I'm just going to ask you to create your own personal account. Once it asks you to create a personal account, I very simply like to just trust Google. Since we use Google products, we're going to sign in with Google. So when you click in sign in with Google, it should have a little pop-up that asks you what Google account you would want to use, and make sure you use your bsd7students.org email address. And I just like to be consistent and use my PowerSchool password, the 4-digit 4-number password that you use for PowerSchool. So for me, I've got my personal email. I also have my bsd7.org. I've already created an account through this. So I'm just going to go through and pretend that I've already done it, and let me know if you end up having any issues there. So once you've got your account, you'll just hit sign in. Make sure you hit sign in with Google. Do your bsd7students.org email, and here's your home screen. Now, unlike certain other CAD softwares, TinkerCAD actually will allow you to do what we have done in Onshape, or it will allow you to make some different designs and allow you to pursue that kind of stuff. The one thing that's really cool is I like to use this button right here that says circuits. We are going to end up creating our own circuit. So on the left hand side, you saw me hit circuits, and we are going to create a new circuit. Now I'm going to try and watch my camera and make sure that my webcam's not in the way. If it does end up getting in the way, I'll just turn it off real quick. But okay, so now you have this totally blank canvas where you can actually start to design your own circuits. What you will see on the right hand side is there are some basic components for you to be able to actually start building a circuit, and we need two things to start right from the get-go. Every single student in class has a set of this, and you will need, if you scroll down on the right side a couple clicks, you'll see an Arduino Uno R3. So you simply just grab that, drag it into place, and we will also need a small breadboard. So we're going to grab that and put it into place as well. So what you'll notice is there's actually kind of a pretend USB connector. So we are actually going to be connecting these to our computers at school to be able to not only one, power them, but for two, so that we can upload code to it. And we'll get to code towards the end. What you need to know about these two pieces is that because of this board, you'll notice that there's a bunch of little holes all the way across the top side, as well as a bunch of little holes along the bottom. This is where you would actually have all of your code, and this is where you would start to put a lot of inputs into place. Then you have a breadboard. The breadboard is where we're going to put all of our components. So if you notice on this right side, there's a ton of things that we can actually incorporate. We can incorporate resistors, we can incorporate LEDs, things such as push buttons, potentiometers, capacitors, switches, different batteries, all sorts of really cool stuff. So if you can imagine, we have almost like endless possibilities of what we can make using an Arduino. And what's really cool, these things only cost like $40. Now I'm sitting here thinking, yeah, $40 is pretty pricey, but realistically, some of the things that you can do with it for just $40, super cool. The one that we end up actually using in class is called a SparkFun Red Board. I highly recommend SparkFun Company for electronics. So if you really get into this unit and you want to have some electronics at home so you can do your own projects, highly, highly, highly recommend. I've gone through at least 3 or 4 of these red boards in my life, and I plan on teaching these for a long time. The SparkFun Red Board is kind of like just a different brand of Arduino board. So if you notice that this one says Arduino Uno, Arduino was like the Kleenex of facial tissues. It's like that is the brand, and that is the cool microcontroller that you use. And then everything else is just the off-brand. But SparkFun works really well. I also have a couple Arduino Unos. They're both the same thing. They're both awesome. They're very, very cool. So, first couple of things I like to do, I'm going to reorient my view so that you can see these a little bit better. We're going to kind of ignore this bottom side with this big chip for right now, and we're going to focus largely on these pins as well as this breadboard right here. So, you'll notice on the display in the upper left hand, there's a few different options. Like if I ended up not wanting to have this Arduino board, I could throw it in the trash. There's also undo and redo buttons, but the big one that I like to use is this rotate. It's on the far left side, right under the TinkerCAD logo. So I'm going to hit that a few times. Get this moved into place. Make sure that you can still see it. I might squish my webcam on my recording just a hair. There we go. Okay, so we've got that in place. Now we're going to grab our breadboard. Make sure that it is positioned such that the letters are at the top and the numbers are on the right side. I'm also going to do a little bit of zooming in so you can see this a little bit better and a little bit more clearly. Okay. Now, what we are going to do, is we are going to start by kind of explaining what we're going to do. We are going to end up getting an LED to light up. If you notice on the right side, I scroll all the way to the top. We are going to be designing an LED to blink. Now, first thing that we have to do is I have to talk to you about how circuits work. Basically, we end up having something such as an LED that we want to power up. This little guy takes about 3.5 to 5 volts to power up, which means that we need to be able to supply it with an amount of energy. And that's where the Arduino comes into play. The Arduino, if you notice all these pins that have numbers, that's your positive power source. And then we have our ground, our GND, which is then the end of our circuit. So through this little LED, we've got 2 prongs. You're going to notice that these 2 LEDs are actually a little bit different in length. The left side to my left, it looks like, is a little bit longer than the right. And we are going to pass electricity through those 2 leads to then get this light bulb to light up. Now, this thing, like I said, it's called an LED. It's called a light emitting diode. A light emitting diode. So this is called a diode, but it emits light. As soon as electricity passes through it in the proper fashion, it will light up. So, in order for us to complete a good circuit, we need to have a positive energy coming from one end and a negative energy coming out the other. So I'm going to show you what that circuit looks like. Basically, we're going to start from pin 13 as being our positive source, just because that's going to be the one that's most common for all of us, because that's where we end up starting in most of our electronics. So what you kind of saw me earlier is that as soon as I clicked on any one of these pins, you're seeing that I am literally pulling a wire out of thin air. All I did was left click, and I started pulling a wire out of thin air. Okay. Now, before I actually start building this is going to get a little bit confusing. I want to talk to you about how breadboards work. Basically, you're going to notice on the far left side there's a plus. Next to that is a minus. And then we're going to jump a space where there's letters and numbers. And then there's going to be different rows. Basically, the way a circuit works is I want to be able to, let's say if I wanted to try and ground my circuit board. What you'll notice as soon as I go from GND to this negative column, all of those in little pins under the negative column will light up. First two things that you should take note of is that on breadboards, doing some weird things with that wire. Let me get rid of that using the escape key. The first two columns, remember columns, and if you're thinking about like the Colosseum and Greek architecture, columns face up and down, and rows go horizontally side to side. The positive and negative columns are all connected all the way down the breadboard. What's really cool about that is if I go from this ground to this pin here, all of these are now grounded, which means then I could say, grab a wire from here to the first row. That's now grounded. I could grab a wire from here to the 9th row. That's now grounded. That's going to be really vital for us once we start getting into some bigger circuits. For right now, we just need one ground going into a minus, and then we're going to pin 13 into the positive. Okay, so it's kind of already starting to get a little bit convoluted just because we're crossing wires here. So, a couple things that I like to do to make sure that this is very clear is you'll notice that when I clicked on the wire, there's a little box that popped up. That box allows us to change the color of our wires. Now, what are you noticing? Positive is red. Negative is black. That's very universal. Any circuits that you see, if you've ever attached something to a 9-volt battery, if you've seen wires of pretty much any kind, black is very universally negative and red is very universally positive. Think about your battery on your car. If you haven't ever seen a battery on a car, ask your mom or dad or whoever to pop their hood and show you the battery, and you're going to see right away red wire, black wire, positive, negative. So, since I'm on pin 13, and this will kind of make more sense once we get into coding, but we're going to start by having our positive energy coming from red, which means I'm going to change that wire to red, and I will change this wire to black. Okay, I have now grounded and put a positive energy on each of these two. Okay. Next thing is we need to get an LED onto our breadboard. One thing that I forgot to mention, and you probably have figured out, is that rows 1 through 30, I believe this goes to 30, yep, 1 through 30 are all connected 5 pins horizontally. Now, what you're noticing is that we also have rows across a little gap right here. These are not connected. So on row 26, A, B, C, D, E pins are all connected. F, G, H, I, J pins on row 26 are not connected to A, B, C, D, E, even though they are still on row 26. And then you also notice that we get a repeated column of our positive and negative energies on this side. Okay, so this is how it's kind of organized. Hopefully that makes a little bit more sense once you start putting your electronics together. For the time being, we're going to focus all of our energy on rows like 1 through 5, just to make sure that you have a very clear understanding of where all these are going to go. So I currently have negative energy on this side. Now, what's kind of strange to think about is something called current. If you're talking about electricity, we think about current. Current is what comes from the positive side. The way I like to do my personal circuits, this is just the way that I do things, so this is how I personally teach it, is I always think about electrons. If we remember anything from any of our chemistry classes or any of our science classes, everything on this planet is made up of atoms. Atoms have protons, neutrons, and electrons. Electrons are negatively charged and are very excitable. They're desperate to try and get to a balanced situation, which means that when there's an abundance of electrons, they get really excited, and they are trying to find any sort of connectivity or chemical composition or any chemical structure. I'm not 100% on my chemistry right now, so if I'm a little off base here, don't judge me too hard. But basically, we're trying to balance out our electrons. In the terms of circuits, we're completing the circuit. And so I like to think of starting from my ground and working through negatively like the electrons would, getting back to our positive lead. Okay? So while we're thinking about that, let's go ahead and position our LED. Okay, so I'm going to grab an LED and I'm just going to go ahead and place it. Couple things that you just instantly started to notice. What you should notice right away is there's these two words that pop up underneath each of the LEDs. I've got a cathode and I have what's called an anode. Because I said that this is particularly called a diode. A diode means that an LED is polarized. Now, without getting into too much detail, there's only one way that electricity can run through this LED in particular. It has to have the positive energy coming through the anode or have negative electricity or electrons coming through the cathode or from the reverse side. So a couple identifiers, you'll notice that these legs are different lengths. There's the one on the right has the little squiggly bend, which means that we theoretically think must be a little bit longer. Longer anode, positive. One more time. The longer leg is called the anode, which needs positive current. The cathode, smaller, negative. Okay, so we need to connect a negative wire to this particular leg of our LED. Okay, now what's the problem? The way that I imported this LED, they're in the same row, which means that if I just jumped a negative wire from my negative column to my second row, oops, both legs are now negatively attached. It's not going to work. So we need to rotate this LED. So I'm going to take this guy, I'm going to spin it a few times, and notice the bottom leg is now the shorter one, and the bottom leg is now the longer one, and the top one is the shorter leg. So if I simply just drag this just like that, my wire is now negatively charging the shorter cathode. Okay, so we're on our way. Just to remind you, we are starting from the ground, moving our ground to this negative portion right here, taking another wire from the negative side of our breadboard, putting it into row 2. The placement doesn't really matter as long as you're keeping in mind that row 2 is now negative, or it is now grounded, as I like to say. Okay, so realistically, the other thing that we would need to do is now connect this anode to our positive side. Cool, let's do it. Connect the anode from row 3 to the positive lead there. I'm going to change this to red to remind myself that I'm connected to the anode on this side. And I've completed my circuit. So if I were to attach this to a small battery, this LED would light up. However, that's a little bit too perfect. See, the reason being is this LED, these tiny little LEDs, if I were to hook straight into an Arduino board just the way I have it that you see just now, this thing would pop. This thing would burn out. It's not like a huge cool explosion. It's like there's a little filament inside of here that just burns out and you might make a little popping sound, maybe. And so what we have to do is we have to realize that we are plugging in our Arduino, which has about 5 volts of electricity, which is way too much for this little LED. So, unfortunately, we have to slow down our electricity. We have to slow down our current. And the way we do that is through something called a resistor. A resistor, let me flip my screen back. No, I don't want that orange. Get that out of here. I'm going to change that back to red. Or maybe I just redo it. Who knows why that turned orange. There we go. Okay. A resistor, if you can see right here, is actually a color-coded object that allows us to change, ironically, the resistance of our circuits. So if I click down here, you'll see this weird kind of bulb thing that's got a bunch of bands on it. The bulb is actually ceramic because ceramic is not conductive. If you're thinking about any sort of clay or any sort of ceramic type material, it's not conductive. So it contains that electricity inside of there. Basically, what that resistor looks like, if I were to pop it open, I basically would have my 2 leads that you see plugging into the pins, and then there's a wire that's wrapped around, and basically we're extending our circuit. And so that resistor makes it much farther for that electricity to travel through because it has to. It's so wound up, this wire is so wound up that it actually has to travel a teensy bit farther, which becomes a resistance. It resists the oomph or like the forces behind your electricity, which means that we have an ability to slow down our current. So if I go back to my TinkerCAD, I'm going to go ahead and place my resistor on the anode side of this LED. If you were doing this circuit in a different sense, you do not necessarily need to put the LED on the anode side. We could end up having it connect to the cathode side and the LED will still work. The resistor will still do its part. But since I have most of my circuit built and I've got space here, I'm just going to go ahead and put the resistor down here. Okay. Now, what you should notice, as soon as you place a resistor, it's going to ask for a resistor name and the amount of resistance in thousands of ohms. I can't really zoom in on this, but it looks like an upside down horseshoe. It's the omega symbol if you know anything about the Greek alphabet. We don't really need that much resistance. We're just trying to prevent this LED from popping. So the one that we do in our kits here at school is we're going to change the resistance to 330. 330. Notice how the colors will actually change as well, right? As soon as I typed in 33, two of those bands turned orange, and I type in a 0, and one of those bands turns yellow. I will be showing you a chart in a few weeks of what those mean. We can actually identify what the amount of resistance a resistor has based on the color bands on it. So I'm going to change this to 330, and then you'll notice that there's a little drop-down menu. I'm going to change this from K omega to just the omega symbol. Now remember that omega in this situation is ohms, O-H-M-S. These are ohms. So I'm going to go ahead and put that, and you should get a resistor that's orange, orange, brown, gold. So that means that we have a 3, a 3, 1, 0, and then the gold band is tolerance. So that means that it's not going to be perfectly 330 ohms. There's about a 1 to 2% tolerance is what we call it. So that resistor is done. So I'm going to hit escape. Now, because we ended up connecting our anode directly to our positive, we need to change this wire. So we're going to click this wire. I'm going to hit delete. And I'm just going to create a new wire. You can see that it's connected on row 7. And I can pick any one of these pins. There we go. Let me do that again. There we go. We're going to change that color to, big no-no. Uh-oh. Mr. Pacer was trying to ground this wire. We want that to be positive. So I'm going to hit escape to clear out of any menus. Hit the delete button. If you notice the delete button on your keyboard, that is paramount to this program. And I'm going to connect it from row 7 back to my positive. Change that to a color red. And you will see that I'm hooked up to positive, and we are on pin 13. Okay, our circuit is done. We've got our LED. It's going in the right direction. We have our negative, we have a resistor, and we're going back to pin 13 on positive. Now, why is pin 13 so important? Basically, on Arduinos, pin 13, since it's right next to the ground button, or the ground pin, we like to use 13 as the default. Why 13? I don't know. Somebody's superstitious and thinks it's funny that we use the unlucky 13 pin. I don't know. Pin 13 is just our default. So next thing we got to do is we've got to code this. I'm going to zoom out a little bit because the code is actually going to push our LED off to the side a little bit. So I'm going to zoom back out, and I'm going to hit code. And you'll notice, if any of you have ever done the hour of code or have taken a coding class, TinkerCAD uses block style coding. So block coding means that we can grab any one of these blocks and pull it over. Just to kind of get you started, I would rather you focus more on the actual circuit and then just copy what I'm doing for coding for right now. When we actually get to our marble sorters, we'll need to figure out how to use something called Arduino IDE. That's a ways down the road. So for right now, block coding is going to be perfect. What you'll notice in my code for right now, I can't really zoom in on this too far, unfortunately, but the default for me having this LED is it's going to say set built-in LED to high, which means on. Set built-in LED to high means it's going to turn on. Then what it's going to do is it's going to wait for a second. So the light's going to turn on, wait for 1 second, and then it says set built-in LED to low. Turns off. And then it waits for 1 second. So if we did this correctly, we should have our red LED come on for 1 second, turn off for 1 second. This is what we call loop. Because then that means once it's looped, 1 more second goes by after it's off, the light will turn on, turn off for 1 second, turn back on for another second, turn off for another second. And it will just keep doing that until you either throw your Arduino out the window or you shut down your computer frustratingly because I don't know why. I'm just being dramatic. So let's try a simulation. So I hit code and I'm going to hit start simulation. So I start simulation. You're going to see my LED comes on and turns off. Comes on, turns off. You made your first circuit. Congratulations. Now a couple things I want to clarify. When it says set built-in LED to high, our built-in LED is actually, if you can see my cursor, the built-in LED that's on the Arduino. That's why we use pin 13. Whatever this LED is doing on the Arduino, we are default setting that to pin 13. Okay? So, what if I don't want to use pin 13? What if I wanted to use pin 9? Let's stop our simulation and let's go ahead and look and see what would happen if I got rid of this and instead wired pin 9 to our positive and tried to play the code. Our LED lights back up, but the LED on our breadboard's not home. Nobody's home. That's because this is where the programming aspect comes into play. We need to tell the Arduino we're not using the built-in LED anymore. We're going to use pin 9. So this code that we've dragged and dropped over here, actually we didn't do anything because that was open by default. We are going to change this. So I'm going to stop simulation and I'm going to take this code and drop it right into the garbage can. I do not want it anymore. It is no longer useful. Instead, you're going to notice that we're going to have all sorts of different organized blocks that we can end up using. So if you notice on output, output means the LED lighting up. The result of us programming this Arduino is that the output is that we get an LED to light up. That's the whole thing. So on output, I'm going to drag and drop set pin with this 0 with a little drop down next to it to high, and I'm going to bring in 2 of those. Then I'm going to go to this orange button that says control, and then we're going to input a delay, or what this one says is wait 1 seconds. I'm going to import 2 of those, and I'm just going to go ahead and snap them to my 2 set pins. Oh, did you hear that little? It did it for me. I didn't even have to do it. Now, once those are set, then I'm going to go back and connect those again, making that popping sound. And I'm going to change set pin from 0 to 9. 0 to 9. 0 to 9. And then we're going to check it, see if it works. Uh-oh. It's not turning off. That's because we needed to change our too high on one of these to low. So we actually need to turn it off at some point. So I'm going to stop the simulation. I'm going to, just for the giggles, I'm going to change this top one to low. This should work pretty much the same thing. It's just going to be off first and then turn on to high after 1 second. So start the simulation. Off, on, off, on, off, on. Bingo. So then what you can do is you can change from wait to, I'm going to change that to 5. Oops, changed my camera on accident. So I'm going to change this to 5. And then we're going to wait 2 seconds to turn on. So it'll only be on for 2 seconds, but off for 5. So let's try it again. 2, 3, 4, 5. Bing, bing. 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 1, 2, 1, 2. We got it. Okay, we're done with doing that. This is your first circuit, and you've programmed your first circuit. So, your homework assignment is we're going to see if we can't end up programming 5 different LEDs to blink at different times. Okay? Now, what's going to be tough about this is you need to figure out how we're going to code 5 different LEDs to blink at different times. Okay? The big thing that you need to learn from this is how do I manipulate my code to make it work properly. First thing you got to do is figure out how to set up 5 LEDs without making it super convoluted. First thing that you're going to see, I'm going to stop simulation. I'm going to hide my code so that you can see my circuit. We can't put pin 9 on this entire thing, right? If I wanted to pin 12, 11, 10, 9, and 8 to different LEDs, that's not going to work. So we're going to save some space. And the way that you do that is we're actually going to manipulate our ground and wires directly to the places that we need them to go. So we're not going to end up using this positive column at all. Because I have so many different places I needed to pin out for different positives, this will be useless. We're also going to largely utilize our negative. So the first thing I'm going to do, I'm going to get rid of that wire, this wire, so that we have one wire going to the negative, so this column is still grounded, and we're going to leave our LED and our resistor. Okay? Now, the cool thing about your resistor is I can rotate this and actually place one end directly into the ground. So instead of having a wire to the resistor and then having the resistor go to the LED, I simply just put the resistor right into the ground, and then I'm going to attach the LED. So remember, I said that you don't necessarily need to have the resistor on the cathode or on the anode side. I can also have it on the cathode side. So I'm going to go through and I'm going to make a couple copies of these. So I'm going to hit Command C on Mac. Command means control, and then C to copy. Command or Control V as in Victor for paste. That has never made sense to me, but Victor for paste. And I'm going to go through and I'm going to place down a bunch of resistors that are connected. That are connected right to my ground. Okay, I zoomed out a little bit too far. Okay, now I'm going to do the same thing for my LEDs. Command V, and what's cool about these LEDs is I can change these colors. So I'm going to change that one to green, change that one to yellow, change that one to blue, and then this one to white. Okay, now what we need to do is actually pin all of our anodes to the positive pins. Okay, so I'm going to take this wire to 12, this one to 11, this one to 10, this one to 9, this one to 8. And then I'm also going to change all of my wires so that they match the LED. So that was the red one. This will be to the green LED. This one is the yellow LED, even though it looks kind of brown. Not purple. I'm going to do blue. And then this last one is white. Okay, so I have wired in 5 LEDs with 5 resistors. And now we need to start coding it. So we've already set pin 9 to be low for 5 seconds, high for 2 seconds. Now I'm going to do that again, except for this time instead of 9, let's do 8. Okay, so I'm going to have it set to pin 8. And I'm just going to keep it so it turns on for 1 second and turns off for 1 second. That's fine. I just want to see if this works. So then we'll start simulation. So I have pin 9. Come on for 2 seconds. Oh, we got some weird things going. So what you need to do is kind of try and figure out how we're going to combine our code to work so that we can turn 5 LEDs on at 5 different intervals. Okay. So that was a really long video. So I'm going to leave explicit instructions in Week at a Glance for this week. You will have the entire week to get this particular circuit done. So 5 LEDs blinking at 5 different intervals. If you're having issues, please send me an email. If you are not going to be able to get this done within a week, please let me know, and I will make sure that we give you a little bit more time to get things done. This is supposed to be a pretty interesting project just to kind of learn the basics of circuits. So if you're confused by anything, please don't hesitate to reach out. And we're going to have a lot of chances to just kind of play around and see what we can end up making. We're going to start introducing some new components next week, and hopefully you will kind of learn some ideas on how we can begin to organize our marble sorters. Don't be thinking about our marble sorters too much just yet, because there's a lot of background stuff we need to do first. So, like I said, this is a long video. As long as you're following along and you get something similar to this, what you will do to turn that in is send a screenshot. So my screenshot on my Mac, I hit Command-Shift-3. Notice that you hear the picture taking sound, and I get 2 images because I have 2 monitors. I have my actual computer, and then I have a monitor on my left to your guys' right. And what you will see on the desktop, on my other monitor, I instantly got a screenshot. If you're on a Chromebook, I don't remember exactly what the command is to take screenshots, but I'm sure you can look it up on Google, or I can try and leave keyboard shortcuts in the Week at a Glance. So, like I said, if you have any questions, don't hesitate to reach out and ask me how things are going, if you have any questions or anything else. And we'll try and have this turned into Canvas under an assignments page by Friday. That's going to be Friday, April already. April 2nd. Friday, April 2nd. Alrighty, thanks for watching. Hope you have a wonderful day.